Just like fractions, multiplying and dividing them is very, very easy. Adding and subtracting them is also very easy, but significantly more time-consuming. Okay? So, we are going to discuss how to add and subtract these things right now. So, when I add and subtract, remember we are dealing with rational expressions. Remember, rational means in this form, x over y. We are add and subtract them the exact same way as adding or subtracting fractions. Now, if you are poopy at adding and subtracting fractions, I would suggest you go and learn how to do it, because Mrs. Badcrumble taught you in the 3rd grade and you practiced it every year ever since. And yet still in pre-calculus 12, Mr. DeVries has to reteach adding fractions. He is nicer than me. Go and learn to add fractions. Okay? Okay. As always, though, I will do one example because that is all you should ever need. We'll start with a real easy one. 2/3 plus 3/5. Why can't I do that as it is written? Michaela? It doesn't have the same denominator. Those are different size pieces of a whole. So you cannot add them together. Mrs. Badcrumble taught you to find a common denominator. Hopefully she taught you why you find a common denominator. I'm not gonna, because she hopefully already did. If she didn't, every time I show you guys why something works, you don't pay attention anyway. You just come up to me and say, how do I do this? So I'm just going to go to how you do this now. Michaela discussed the fact that you need a common denominator. What is that common denominator? 15. Now, all of you automatically know that it's 15. Why is it 15? Because 15 is the lowest common multiple of 3 and 5, yes? So what I need is a denominator that incorporates both of these, correct? Right? How do I do that? Well, in my head, because this is so easy, I know that it's 15. But what you really did is you multiplied that by 5 and you multiplied that by 3, didn't you? You needed 15 because 15 would take care of both of these. Then, what do you have to do to their partners? The same thing. So you needed to multiply this guy by 5, so you need to multiply this guy by 5 to get 10. You needed to multiply this guy by 3, so you need to multiply this guy by 3 to get 9. To get 19 fittings. Yeah? Yeah? Everybody is good? Everybody remembers how to do this? Okay, now let's talk about what you actually... Yes? Okay. Let's talk about what you actually did. Okay? What you actually did here, and I'm not going to write it down, is you found the denominator here that covered every term in the question, yes? So your denominator in a rational expression, when you're adding it, must account for everything. Does everybody understand what I'm saying? Then you adjust your numerators. Then you perform the addition or subtraction, okay? That's what we do with a fraction question. It's the same thing here, except we have expressions, not single terms. So, before we're going to do anything with this, what do you think we do if I don't have a single term there? It's what we've been practicing all along. The first step is always factor. Factor, factor, factor. Because that simplifies things. All right? Once you factor, then you seek your common denominator. Denominator. I still have to sound that out to write it. Now here's the trick. When it's numbers, it's real easy to see, isn't it? 5 and 3 was 15, yeah? But what if it's not numbers? What if it is an expression such as x squared minus 4? Then it's harder to see the common denominators, yes? What was your trick to automatically know that was 15? What did you do? You multiplied your denominators, right? 5 and 3, right? So what do you think you do if it's a rational expression? Multiply your denominators. You get a common denominator by multiplying all your denominators together. I'm going to be lazy and write dens together. Now I'm going to give you a big hint here, and I'm going to write it in red. Don't expand. And I'm going to highlight it even. And you're going to see what I mean in a minute. Then, once you have changed that denominator, you have to adjust your numerator, yes? Right? So what do you think we would do in a rational expression? The next thing is we adjust our numerators. How do we adjust numerators in a fraction? We multiplied by what we needed to, yes? We multiplied by that factor of the common denominator, right? So here we adjust our numerators by doing what? Multiplying by the denominators, the dens we used. And then step 4, which I ran out of room for, is obviously add and subtract. Okay? Now the first 3 here are very easy. Why? What about 1, 2, and 3 makes them no-brainers? They have common denominators, don't they? So this is really over what? B. And what would I write in the numerator? It's a little bit tricky here. What's the first numerator? 2a minus, what's the second numerator? A minus 1. Why did I put those brackets? Because that negative is going to do something here, isn't it? What is this answer going to be? A plus 1 over B. What is the one new thing, the one new wrinkle we added to math in the last unit and this unit when faced with the variable denominator? What? No, we added one wrinkle here. What number can B not be? B can equal 0. Right? Everybody cool? Okay, what's the second one? You should be able to do it in your head. What's the numerator? What's the numerator? Pardon? No. That grade 9, it's rearing its ugly head, Joel. 2x plus 8. You can't add x's and 8s. Over what? X plus 4. How many of you think we're done? Why are you not done? Factor, 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 factor. When should we factor in Math 11? Every single expression you see that is factorable should be factored. Do you see a factorable expression there? What? I can take out a 2 here. X plus 4 over X plus 4. Hey, Joel, what does that look like? Canceling. So what's the final answer here? 2. Except there's one little problem. X can't equal what? -4. Everybody cool? Okay. What about the third one? What's the denominator? X minus 2. What's the numerator? Would we leave it like that? Of course not. Why? Factor the top. X plus 5. X minus 2 over X minus 2. Hey, Joel. What do we do? Cancel. And what's the final answer? X plus 5. But X cannot equal 2. Is everybody good when the denominators are the same? Everyone. You're liars. But that's all right. Oh, good gravy. What has happened in number 4? Macaulay Culkin left at home. What's wrong with it? There is no common denominator. Now, for there to be a common denominator, every part of all the denominators must be there, yes? When it was 3 and 5, we used 15, because 15 covered the 3 and the 5, yes? Okay, so when I look at this, I say to myself, I say, self, I need a denominator that has what parts? It has an x squared. What else? It has an xy, and what else? A 1. Correct? Everybody agree that that is what I need in the denominator? Everyone understands what I'm talking about, yeah? Okay. Now let's look at that situation. If I need an x squared, where's my dot not moving? Why is my dot not moving? Does this 1 matter? No. Okay. Now, here is what I need, yes? I need an x squared and I need a y, yeah? Okay. What does this section need? Does it have the xy? So what does it need? The x squared. So this guy must multiply by what? X squared, because he's already got the xy. What does this guy have? X squared. So what does he got to multiply by? Just the y. He's already covering the x. Everybody cool? And what about this guy? He needs both. So he needs x squared and a y. Now, all of you should be looking at this right now and saying, hey, wait a minute. Why do we have x squared and xy? Doesn't that x squared cover that x? So I really only need down here x squared and y. Everybody understand? So down here, I recognize that the x squared is covered, so I really only need x squared y, yes? Now, look at this. What is going to happen with x and x? They're going to cancel, so what's the only thing left here? 2 times x squared is what? 2x squared. Any canceling in the middle term? I got a 4 over x. Any canceling? No. The 4 had to multiply by y. So it's plus 4y, yes? Any canceling in 3 over 1? No. So the 3 needs the whole denominator, 3x squared y. Does everybody understand? We're going to do a bunch of these. Do you have an inkling of what is going on? When you read my notes at the beginning, you will see what I mean. Remember, common denominator is everything I need. So I needed an x squared and a y. That x was covered. Everyone good? The only way to get good is to practice. So we're going to turn the page over. We're going to try some significantly more difficult ones. That's done. Done. Okay. Look at this question. Tell me what you think you should do right away. You should factor anything you can. Right? There's 4 options here. Only one thing there is factorable. What? Y squared minus 4, because it's a difference of squares, yes? So we're going to go ahead and factor that. Y squared minus 20 over y plus 2, y minus 2, plus y minus 2 over y plus 2. Everyone agree? Everyone's cool, yeah? Okay. Now I am adding 2 fractions, yes? Are the denominators the same? Almost, but not quite, right? I need the denominator to have one of everything. I got the yellow denominator, I got the green denominator. Which denominator has more stuff? The yellow. So the yellow is my base, right? Like if I'm adding thirds and fifths, right? I got to go up from the fifths, yeah? Because I've got to at least cover that 5. Everybody with me? So here I've got to go up from the yellow. So I look at the yellow denominator and I see there's a y plus 2 and a y minus 2. Now look over here. Which is covered by the green? The y plus 2, yes? So this side must need what? A y minus 2. Everybody with me? Does this term have everything covered? Yes. So does this numerator have to change? No. Everybody with me? It's exactly like this question. 3/4 plus 5/8. What's the denominator that you need? 8. So you didn't change this guy because he already had an 8, yes? The denominator we need is this. Yellow's already got it, so I don't change yellow's numerator. Everybody cool? So that stays. Y squared minus 20. Plus, now, what do I got to do here? I said not to expand in the denominator, but what do I got to do here? I had to multiply this by 2 and expand it, didn't I? So what do I got to do here? Expand it. Y squared minus 4y plus 4, yes? Is everyone okay with that? Yeah? Okay. Now, what does it give me in this numerator? What can I do with all of that? Collect like terms, just like the 9th grade. Any other y squareds? 1 plus 1, 2y squared. Negative 20 plus 4, what's that? Negative 16. And in the middle here, there's a negative 4y, yes? Everybody cool with that? Over, what's our denominator? Y plus 2, y minus 2. If you got to there, am I happy? Have you added the fractions together? Have you technically done the job? Yes. Much like if you cheated here and said it was over 32, because you did 8 times 4, and did 24 plus 20, and got 44 over 32. Is that technically the right answer? Yes. Is any math teacher going to be happy with that? No. They'll be like, oh, the kid kind of gets it. Okay, I'm going to give him a C. Because what should you do there? Simplify. So what should we do here? Simplify. How do we simplify in grade 11? Factor, factor, factor. What's coming out of there? 2. Y squared minus 2y minus 8 over y plus 2, y minus 2. Now what? Factor again. 2. Y plus what? 2 and y minus 4 over y. Joel, you're giving me away. Spoiler alert. Now what? Cancel, cancel. What's left? 2 y minus 4 over y minus 2. It's long, it's involved, but there is nothing new. It's every single thing you've ever learned from grade 3. And your teachers told you all the way along, eventually it's all going to get put together. And you were like, whatever. And yet, here we are putting it all together, yes? Remember, what can y not equal? Plus or minus 2. Everybody good? All right. Now remember, I say it again. This is all about practice. There's no skill. It's just practice. So have a look at number 6. What's different? The denominators are different, and the denominators are where we need to factor this time, isn't it? So we're not changing numerators yet. X minus 1 over, how do I factor that first one? You guys go ahead and factor that. The yellow one. Then go ahead and factor the blue one. So what's yellow guy? X plus 3, x minus 2. Does order matter? No. I could have done x minus 2, x plus 3. But could I have done x plus 2, x minus 3? No. What's this guy? X plus 3, x plus 1. Yes? So now I need my common denominator. What are all the components of the denominator right now? There's an x plus 3. There's an x plus 1. Forgot the 1. And there's an x minus 2, correct? Does that cover all parts of my denominator? Plus 3, minus 2, plus 1, plus 1. I've already covered the plus 3. Everybody cool? All right, now, I need all 3 of these in the denominator, don't I? What do I have here? I have 2 of them. So this term must need to multiply by the third one, right? What's missing here? X plus 1. So what does this guy have to multiply by? X plus 1. What's this guy missing? X minus 2. So what does this guy have to multiply by? X minus 2. Right? And then we go. X squared minus 1 minus x squared minus 4x plus 4, yes? Simplify again. What's x squared minus x squared? Gone. What's negative 1 minus 4? Negative 1 minus 4. I'll say it again. What's negative 1 minus 4? Negative 5. That took a little longer than I would have expected for 11th graders. Oh, did he say? I thought he said negative 4. Oh, I'm sorry, Lucas. Look at my ears. They're old. There's gray hair in them is how old my ears are. It's coming for you, buddy. No. You're cool. Sorry. And what's negative 4? Positive 4. So I get 4x minus 5 over that bottom. X plus 3, x plus 1, x minus 2. Is there any more factoring and or canceling? No. So we're done. Except what? X can't equal what? 2, negative 3, negative 1. Is everybody good? Okay. Oh my good gravy. There's fractions on top of fractions. What madness is this? Holy crap. Whew. What should I do with that? What if it was only this yellow? Then it would be 1 plus 1 over x, wouldn't it? Do we know how to deal with that? Sure we do. What's the common denominator? X. Is this guy already xy? So does his numerator change? Is this guy xy? So what does he have to multiply by? X. So I get x plus 1 over x. Everybody cool? I have an answer, Mr. Orsted. No, because they're stuck. This is what Jordan asked yesterday, remember? So is everybody cool with what I did there? Everyone's cool with what I did there? Okay. What's the blue one? If I wrote it out, it would be x minus 1 over x, yes? What's my common denominator? X. Does this guy already have x? So is this guy changing? No. This guy, what's this guy's denominator? 1. So does this guy need an x? So he multiplies by x. So what do we get? X squared. So this is what I really have, isn't it? I have that divided by that, don't I? That's what I have, yeah? Didn't we do this yesterday? This is x plus 1 over x divided by x squared minus 1 over x. What do you do with divided by? Flip the second one. So it's x plus 1 over x times x over x squared minus 1, yes? What do I get to do with those x's? Joel, before I cancel, what should I have done? I tricked you. Factor. X plus 1 over x times x, x plus 1, x minus 1. Now what? Now, Joel. Cancel. Where? The x's and the x plus 1. Leaving me with 1 over x minus 1. Everybody cool? Do I have Non-permissible values. Yes, x cannot be 0 because that gives me 0 fractions everywhere. And what else can't x be? Plus or minus 1, because right there I'd have a 0. Any questions? Nothing new, right? Nothing new. The hardest thing, I think, is deciding what your denominator must be. Right? But all it is every denominator you have. And then what you need in which numerator. Is everybody with me on this? Everybody understand? Right? Okay. So I'm going to stop recording.